Okay, so now we're going to talk about representations and algorithms. And to talk about that, first I want to go back. Right? We talk about oops, sorry. We we talk about how, the mind is an information processing machine, right? It transforms incoming information uh, through internal mental processes, derives some kind of output. Well, so what is information processing? Well, it involves present representations. Uh, it involves constructing representations of the world and applying some sort of algorithm to these representations. So what's a representation? A representation is simply just, you are representing in your mind something that stands for something in the real world, right? So if I say the word dog, that word dog, that representation dog, it represents the external thing in the world that is a dog, right? Um, and so, yeah, so processing information involves constructing representations and then applying some sort of algorithm to these representations to process that information. So, for example, when I talk about representations, we can talk about numbers. So, 53 plus 24 plus 75. These are all going to be representations, right? Each number is a representation. It represents 53 of something, 24 of something, 75 of something. Okay. And if it's a problem, if you're trying to add the three numbers together, you can apply a standard US algorithm, right? Which is right where I put the numbers in a column, matching up the numbers places, and draw a line beneath them, right? So that's what I did here. And then you add the ones column. So 3 plus 4 plus 5. What is that? 7 plus 5 is 12. So then if the sum is greater than 9, which it is in our case, we write down the units digit of the sum in the current column and carry the tens digit to the next column on the left. Right? So we put the 2 underneath and then we put the 1 at the top of the tens column. And then we add the tens column. So 1 plus 5, that's 6. 6 plus 2 is 8. 8 plus 7, that's 15. Okay, so if the sum is greater than 9, which in our case it is, we write down the units digit in the sum in the current column and carry over the tens digit to the column in the next column on the left. In this case, we just add them all up and it becomes 15. So then that's 152. Um, yeah. So now, notice though how this is one way, one type of algorithm, right? But we can do there are other types of algorithms that exist. For example, the Common Core algorithm I'm sure some of you are aware of it. Hopefully. What you do here is it's slightly different, right? So you say, okay, add the ones place values together. So then that means 3 plus 4 plus 5 equals 12, and then add the tens placed together. Okay, so then that's 50 plus 20 plus 70 is 140. And then you combine the sums from the tens and ones places. So 12 plus 140 is 152. And this is all to show that, different algorithms can be used to compute a different function or a given function, the same function, right? And this is, important, right? The thing that I want you to realize is that the way that not only can we use different algorithms, but the way in which we represent certain information has implications for how useful that can be in a given operation. So, we use numbers we represent numbers using the Arabic system of base 10. In fact, a lot of math comes from the Arab world. They did a lot of work on math during the Dark Ages. Uh, so, I mean, we can think of, we use Arabic system, but you can use the binary system of base 2, right? Or you could use Roman numerals, right? We use Roman numerals in like sports, but we can use it everywhere if we wanted to. We could also use hexadecimal, which is base 16. I don't know anything about basics about hexadecimal, but you can still use it. The important thing is I think we can all agree that if we were to try to apply either this US standard algorithm or the Common Core algorithm, it would be ridiculous to try to use a Roman numeral system uh, or even a binary base two system, right? It's not conducive. Those types of algorithms will not be conducive to that type of representation, right? So that is says all to say is how information is represented greatly affects how useful it can be, right? And so any particular representation will necessarily make certain information more salient at the expense of information that's pushed into the background, right? Or might be more harder to recover. And the choice of how something is represented is incredibly important because it determines what's made more easily accessible, which affects how efficiently certain operations can be performed with it. Okay, and then in the next video, we'll talk a little bit about um, Mars levels and multiple realizability.